In this session, we study about the application of matrix. In this application, we see how to solve simultaneous linear equations. For this, I have taken one example, one numerical is on our screen, so that the following system of linear equation is consistent and also find the solution. There are two things have been asked to us. Number one is consistency. And number two is solution. In systems of linear equations, if there is consistent, the system is consistent, then we could get the solution. Otherwise, we are unable to get the solution. So first of all, whenever we have to solve linear equation, we should know about the consistency of the systems. If the system is consistent, then we could get the solution. Now, through matrix, how we solve this sort of linear equations of two variables or three variables? We take an assumption. You look at this on our screen here. Matrix A into matrix X is equal to B. This assumption we take, and then we get X is equal to inverse of matrix A into B. So how we get matrix A, how we get matrix X, and how we get matrix B out of this system of linear equations. So I explain you about A, X and B first, then I will explain this assumption again. So we get a matrix A here. Matrix A Matrix A is the coefficient of all the variables we have to put down here in this matrix A. The coefficient in the first equation, there are three equations we have. This one is first, this one is second, and this one is third equation. We have three equations here. So we get the coefficients of all the variables. There are three variables are there in each equation. You see x, y, and j. So in the first equation, we see the coefficient of x is 1. In the second, coefficient of y, in the first equation, the second variable coefficient of y is also 1, and the coefficient of z is minus 1. This we have got here. And here you see in the second equation, the coefficient of x is 2, coefficient of y is 3, and coefficient of z is 1 again. And here you see in the third equation, coefficient of x is 3, coefficient of y is minus 1, and coefficient of z is minus 7. So this is our matrix A. Now, what is matrix B? Matrix B is equal to, what is matrix B? We have to first now we see what is matrix X. Matrix X is the matrix of order 3 by 1 of all the variables. we have to put the variables in this way, in the column form: x, y, and z. These are the variables we have to write in matrix A. And the matrix A is 3 by 3 matrix because the coefficients of all the variables here. And now look at matrix B. What is matrix B? Matrix B is the matrix of 3 by 1 order, which is the matrix of the constants on the right side of these simultaneous linear equations: 3, 10, 1. This would be the matrix B. 3, 10, 1. So now you have got matrix A, matrix X, matrix B. Now I would like to explain something more. Look at this. We have written that A into X is equal to B. We have to find the value of X, Y, Z. So this matrix X will remain here, and A would be transferred to other side, B over E. Now here you see matrix A is 3 by 3 matrix. First we change the color here. Sorry, it is 3 by 3 matrix. A matrix B is 3 by 1 matrix. If I get the inverse of this matrix A, I write in this way here: X is equal to A inverse B. Now look at this. It is 3 by 3. It is 3 by 1. So you get here final matrix of 3 by 1. X would be 3 by 1. So it would be in the form of like X is. So this multiplication would be in the form of 3 by 1. So we can equalize this and we can compare this, or we could get the value of X, Y, and Z. Why we are not putting A inverse behind B? I explain you this also. If I put X is equal to B into A inverse, now you see the order of matrix B is 3 by 1. Here you see, and the order of A is 3 by 3. So look at this. There is no chance of getting the multiplication of this B into A inverse. So we take always in this form. We always take in this form. X is equal to A inverse B. Look at this here also. So what we have to find out here, if we have to find out the value of X, matrix X, then we have to find out the value of A inverse. Okay. So in the previous session we have studied about the A inverse by the elementary row method and also by the adjoint. So I solve this through adjoint matrix. So we get C11, C12, C13, all the 4 factors. So let us see what happens. C11 is the element except first column and first row, because the A11 element is this, so this element comes in first row and first column. So leaving the elements of first row and first column, and remaining elements we put in the form of a determinant. So we get here 3, 1, minus 1, minus 7. Now we simplify this determinant, expand it. So we get this is the diagonal. The elements of the diagonals are 3 and minus 7. So we multiply, we get the product of the elements of the diagonals, 3 into minus 7, and subtract the product of off diagonals elements. The off diagonal elements are 1 and minus 1. We get the product of these 1 into minus 1 and subtract this from the elements of main diagonal. So we get here minus 21, and here you see minus into minus plus, it is 1. So we get here minus 20. So minus 20 is we have C11. Now look at C12. Here you see the sum of 1 plus 2 is 3. So we have to choose, it is odd, so we have to get the negative sign outside this determinant. Whenever there is odd, the sum is odd, we have to take the negative sign. We have explained in earlier session. So here 1, 2, A12 is element this one. So we have to leave this column and this row. First column and second row we have to give up, and we have to take the elements except this 2, 1, 3, minus 7. So we take here 2, 1, 3, minus 7. Now we expand this, minus multiplication of the elements of main diagonal, 2 into minus 7, subtract the product of elements of off diagonal, it is 1 into 3. So we get here minus 14 minus 3. Now look at this, we get here minus 17. Finally we get 17. So C12 is 17. Now we get C13. In C13 you see the sum of 1 plus 3 is 4, which is even. So we don't have to take the negative sign, we will get the positive sign. We take the positive sign here outside. So this is A13. So it is in first row and the third column. So remaining these elements of first row and third column, the remaining elements we will take is in this determinant. The elements are 2, 3, 3, minus 1. So the same process we will follow, 2 into minus 1, minus 3 into 3. So it is minus 2, minus 9, which would be minus 11. So this is C13. Now C21. Here you see this, in C21 you see 2 plus 1 is 3, which is odd. So we have to put the negative sign outside this determinants. And C21, A21 is 2. So we have to take the elements 1, minus 1, minus 1, minus 6. 1, minus 1, minus 1, minus 6. So we get here, negative sign outside, 1 into minus 7 minus 1 into minus 1. So we get here minus 7 minus 1, so which would be minus 8. So we get here 8. Okay. C22, it is even. We get the positive sign outside this. No need of put the sign here. It is the A22 elements. We have to leave this column and this row. The remaining elements we have to write in this different 1, minus 1, 3, minus 7. 1, minus 1, 3, minus 7. Now we expand this. 1 into minus 7 minus 1 into 3. So we get here minus 7 plus 3. We have got minus 4. Now C23. It is the odd, 2 plus 3 is odd, so we have to get the negative sign outside this, and we put the value. 2 3 element is this, so we have to leave this column and this row. The remaining element, this column and this row, and the remaining element we have 1 1 3 minus 1. We have 1 1 3 minus 1. We have this now. So it is negative sign outside, 1 into minus 1 minus 1 into 3. So we get here minus 1 minus 3, which is minus 4, or which will be 4. It is 2 3. Now C31. It is even, so don't need to put the negative sign outside. So here you see 3 1 is this one element is 3 1, so we have to leave this column and this row. The remaining elements we have to put here 1 minus 1 3 1. So we have to put 1 minus 1 3 1. 1 minus 1 3 1. Now we solve this. 1 multiplied by 1 minus 1 multiplied by 3. So we get here 1 plus 3, which is 4 now. Okay. Now C32. Now you see it is the odd. The sum of 3 plus 2 is odd. So we have to put the negative sign here. So 32 element is this minus 1. So we have to leave out this column and this row. So we get the elements 1 minus 1 2 1. 1 minus 1 2 1. 1 minus 1 2 1. So we get here negative sign is outside. 1 into 1 minus 1 into 2. So we get here 1 plus 2. So we get here minus 3. Now the last cofactor C33. It is even. C3 plus 3 is 6. Even, no need to take the negative sign outside. So the 3 3 element is this one minus 7. So we have to leave this column and this row. The remaining elements 1 1 2 3 we have to take. 1 1 2 3. It is 1 1 2 3. So we get here, expand it, 1 into 3 minus 1 into 2. So we get here 3 minus 2, which is 1. So these we have got all the cofactors. Now we find out adjoint A. Adjoint A is a matrix of cofactors, but it is the transpose matrix of cofactors. So we write the, in this matrix we write C11 here, it is the transpose matrix C12 C13. We don't have to write in this way. It is the transpose matrix C21 C22 C23 C31 C32 C33. In this way we have to write. So we get the adjoint A here. Now we have to find out adjoint A. Adjoint A, we get here adjoint A adjoint A is equal to, write the values what we have find out, the cofactors here, minus 20 17 minus 11, C11 C12 C13 is minus 20 17 minus 11. It is minus 20, it is 17, it is minus, sorry, adjoint A, we look at the cofactors here, C11 C12 C13 minus 20 17 minus 11. We have to write in this way, minus 20 17 and minus 11. C21 C22 C23 we have to write here in second column. So C21 C22 C23 are 8 minus 4 4. It is 8 minus 4 and 4. C31, C32, C33 we see here. 4 minus 3, 1. It is 4 minus 3, 1. Now we have to find out the adjoint we have got here, adjoint A. Now we will find out determinant of A, which is A11 C11 plus A12 C12 plus A13 C13. The elements with their corresponding cofactors we multiply of any column or any row and add this all, so we get the determinant of any one of the row or the column. So we get here determinant A11. Look at this here, A11, A12, A13, 1, 1 minus 1 we have, so we write here 1, and C11 we know that here minus 20, A12 is 1, C12 is 17, plus A13 is minus 1 and C13 is minus 11. So get here minus 20 plus 17 plus 11. So we get here minus 20 plus 28. So we get here 8 is the determinant of A. So the determinant is not singular, it is non-singular determinant. It is not equal to 0. It means the system is consistent. First answer we have got here, the system is consistent. The consistency shows that the value of the determinant is not equal to 0. Now we have to find out the inverse, A inverse. So A inverse is equal to adjoint A over determinant of A. So we'll divide this determinant by 8, this adjoint A matrix by 8, sorry. So we write here adjoint A inverse is equal to adjoint 1 over 8, this is the determinant value 1 by 8, and here minus 20, 8, 4, 17, minus 4, minus 3, minus 11, 4, 1. This is the 11. So this is the A inverse we have got, and now we see the formula how we get the value of x. X is equal to A inverse into B. X is xyz and B is 3, 10, 1, and we have to put in this formula x is equal to A inverse B. So now we put these values here in this formula. X is equal to A inverse into B. We know that X is equal to A inverse, write down here A inverse into B. B we write down here. I put the elements here. This is x, y, z. This is x, y, z. It is 1 over 8. Look at this. Minus 20, 8, 4, 17, minus 4, minus 3, minus 11, 4, 1, and it is 3, 10, 1. You know that it is 3, 10, 1. 3, 10, 1, x, y, z. We multiply these here. It is 1 over 8. It is, we have to the first column with this row, then the second column with this row, and the third column with this row, their corresponding elements. So minus 20 into 3 plus 8 into 10 plus 4 into 1. The first element with first element, second element with second element, and third element with third element. In the second row we will do the same thing. 17 into 3 plus minus 4 into 10 plus minus 3 into 1. So we have got this first element, second element, and third element. Here you see minus 11 into 3 plus 4 into 10 plus 1 into 1. So we got this here. So this is our matrix here. This is our x, y, z we have to put here. Sorry. X, y, z. Now we simplify this. So x, y, z. Simplify here. So we get here x, y, z. It is 1 over 8 here. It is minus 60 plus 80 plus 4. It is 51 minus 40 minus 3. It is minus 33. It is plus 40. It is plus 1. We got here is all. Now, finally, it is x, y, z. It is 1 over 8 here. It is minus 60 plus 80 plus 20 plus 4. It is 24 now. Minus 51 minus 43. It is 8 now. It is minus 33 plus 41. It is again 8 now. So finally we get here we multiply 1 over 8 with each element of this matrix inside. So we see what happens now. It is x, y, z. It is 1 by 8 into 24. It is 1 by 8 into 8. It is 1 by 8 into 8. So get here 8 one time, 8 3 times, 8 one times, here 8 one times. So we get finally the answer. The x, y, z is 3, 1, 1. So finally we have got the answer. X is equal to 3, y is equal to 1, and z is equal to 1. So we have got these answers here through this matrix method. All the simultaneous equations we have got the answer. Thank you.